We will continue the phase variables. I want to erase all these fundamentals of state space analysis. So state variables are represented with the first order differential equations. So let us clear this. Yeah. Let's again write the phase variable notation. So what is a phase variable? Phase variable is nothing but we'll take one of the system variables. So here the system variable is your output. So state variables are output and its derivatives. So here we have two types. The first one is state space representation of nth order system, in which the forcing function does not involve derivative terms. Right. So therefore, we have the state variable as the first state variable as x1, which is equal to output, x2, which is the derivative of the output, x3, another derivative, and so on, x n minus 1, which is y to the power of n minus 2. I think you know the meaning of y to the power of n minus 2. This is n minus 2 at differentiation of the output variable. So what is xn? Xn would be y to the power of n minus 1. And if you look at your equation, that is time domain equation, y to the power of n plus a1 y to the power of n minus 1 plus a2 y to the power of n minus 2 plus a n minus 1 y to the power of 1 plus a n into y to the power of 0. Is equal to dn into u. So this is your equation. So which has the forcing function does not have any derivative terms, right? Right. No. But what we need in the state space analysis, we need x dot 1, right? That is differentiation of the state variable. Right? Since your state equations are x dot of t is equal to a into x of t plus b into u of t, and the output y of t is equal to c into x of t plus d into u of t. This is the state model of any system or LTA system. Okay. Now what is x dot 1? Take the differentiation of the x dot 1. It would be y dot. So what is y dot? Y dot is nothing but y dot is equal to x2, right? So this is equal to x2, right? Similarly, x2 dot is equal to y double dot, which is equal to x3. Right. What is x3 dot? Which is equal to y triple dot, which is equal to x4. So I'll put 3 dots here. And what is x to the power x n minus 1? This is 3 x dot n minus 1, which is equal to, what's the value? Y n minus 1. What is this? This is your last state variable, right? What is this? So this is equal to x n, right? So we got all the first order state variables till x n minus 1. Now what about this x dot n? X dot n, right? So obviously it would be y to the power of n. So what is this value? Okay. Now this value, the last term, can be determined from the equation number 1. Right? Now what is that? X dot 1, or I'll write it here. Okay. X dot n is nothing but your y to the power of n. So what is y to the power of n? This is your y to the power of n. So obviously it would be, take all the terms that side, it will be minus, I can say, let bu. So eliminate this, not bn, let it be b, right? It will be b only, bu minus a1 y to the power of n minus 1 minus a2 y to the power of n minus 2 minus, and so on. Sorry, dot 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 minus a n minus 1 y to the power of 1 minus a n into y. Okay, so this is your last variable. Now let us put all these values in matrix form or in state model equation, right? So what is that? We should put all your x first order differential equations of state variables in terms of matrix A, x of t, and b into u of t. So let us put in matrix. Yes. Let us put in matrix. So what is the first one? X dot of t, right? So I'll keep x dot of t, right? I'll use red color for this. X dot 1, x dot 2, let us say x dot 3, 3 dots, x n minus 1, and just move up x n, right? So this is equal to, now what's the matrix here? A matrix. So what is x dot 1? It is your, what is x dot 1? It is your x2 variable, right? Y dot is equal to your x2 variable. Remember this point. Your x dot 1 is nothing but your x2. You remember this point. So I'll write the matrix here. How do I write? Let us put your matrix like this. As much as possible like this. This is a matrix multiplied by your x of t, right? So what is x of t? X1, x2, x3, 3 dots, x n minus 1, x n plus V matrix into input matrix, that is U, right? Now what is x dot 1 is nothing but your x2. So I can keep 0 here, first element, and I'll keep 1 here and keep zeros till all the values, right? So similarly for x2 dot, I can keep 0 here, 1, 0, 3 dots, 0. So if you multiply them, you will get x dot 1 is equal to x2, x2 dot is equal to x3, right? So similarly 0, 0, 0, 1, 3 dots and all zeros, right? So I'll put here what is the last element? It is 0, 0, 0, 0. So you'll get last one as 1 here. Since x dot, I'll keep x dot n minus 1 is nothing but x, yeah. So we'll get 1 here. Now what about x dot n? So which is nothing but this one, right? This value. Now I can write this as minus an, right? Minus an minus 1 minus an minus 2 minus an minus 3 till see this. What is y here? Y is nothing but your state variable x1, right? So if you rewrite this equation, you will get a2 a1, right? So if you don't understand, you just check the equation, you will get it. Just replace again your y terms by x terms, right? Your state variables. So that is how I will get minus an into y. So what is y? Your first state variable. So we assumed your first state variable is your y here, right? So minus an into y. So that's how you get. You just replace all your y elements by your state variables. You'll get it. Next one, the B matrix. Very simple. Put all zeros here. Since you have only B term, B into U value, so it would be B only, right? So this is how you can write the matrix or state model for the forcing function does not have any derivative terms. Now, what is this now? It is x dot of t is equal to a into x of t plus b into u. Right. Now, what about output value, right? So let us look at that output values. So what is output? We assume that first state variable is your output. So y would be first state variable. So what is the equation here? Y of t must be equivalent to c into x of t plus d into u of t. So in this output, we have only one variable, right? State variable. So your matrix would be x1, x2, x3, 3 dots, xn minus 1, xn plus 0. There is no D matrix, right? So what is output? Output is equal to 1 into x1. Y is equal to x1. We assume this one. So this is how we can represent the phase variables which has no derivative terms of output. So this is about phase variables. Let us consider one example how to do the problem using these variables, right? So we have seen state space representation by physical variables where you have circuit and identify the number of capacitors and inductors. What are the state variables? The currents through inductor and voltages across the capacitor. Those are the state variables of the circuit diagram. So to get the state space analysis, we find the first order differentiation of all state variables. To achieve this, we apply KVL and KCL. Similarly, for these phase variables, so I have one example. Example number 1. So obtain, the question is like this, obtain state model of the transfer function TFS is equal to, so what is TFS? Y of s by U of s, which is equal to 1 by s cube plus 6s square plus 10 into s plus 5. This is the problem. So to obtain state model, first convert your transfer function into time domain function. So that is multiply you should make some cross multiplication, that is y of s into this and u of s into this, right? So that you will get cross multiplying, it would be s cube into y of s plus 6s square into y of s plus 10s into y of s plus 5 into y of s is equal to 1 into u of s, right? Now, how do you get the time domain equation? Just take the inverse Laplace transformation. You will get the time domain equation. Since it is 3, it would be y triple dot, isn't it? Plus 6 into y double dot. That is second differentiation. Plus 10 into y dot. Plus 5 into y, which is equal to u. So this is your time domain equation. Now, how many state variables are required to obtain state model? Again, it depends on the order of the differentiation, right? So how do you find the order? Order is 3. So we need 3 state variables. 3 state variables. Right. Now, how do you assume the state variables? Same procedure. The first state variable x1 must be equal to your output, right? And x2 must be the first derivative of the output, and x3 would be y double dot, right? So now what is first order differentiation? X dot 1 would be y dot, which is equal to x2. So I'm using the same procedure to obtain the state model. X dot 2 is equal to y double dot, which is equal to x3. Now what about this? The last one, x dot 3, which is nothing but your y triple dot. Now how do you get the last one, y triple dot? From the time domain equation. So this is the only critical point in this phase variable. Finding the last state variable from the equation. Now what is y triple dot? So y triple dot is nothing but your minus 6y double dot minus 10y dot minus 5 into y plus u. Right. Now what is y double dot? Y double dot is nothing but your x3, isn't it? So this is nothing but minus 6x3 minus 10. What is y dot? x2 minus 5. What is y? x1 plus u. So which is nothing but your x dot 3. Right. I think now we can put it in the matrix form and we'll obtain the state model. So what is state model? Putting the algebra parameters using state model equations. So what are the state model equations? They are x dot of t is equal to a into x of t plus b into u of t. So what is the output? Y of t is equal to c into x of t plus d into u of t. Right? Now, let us put in matrix form. So that is first one is x dot 1, x dot 2, x dot 3. So this is your x dot of this one, which is equal to, I should have the A matrix. So I'll keep vacant first. Then I have to write the state variables. The number of state variables are x1, x2, and x3. Right? And plus your A matrix into U. Since I know it, what's the value? 0, 1, 0, 0, 0, 1, and minus 5, minus 10, minus 6. Okay, 6. And what about this? This would be 0, 0, and 1. So this is the state model of the given problem. So what about output? We should write this equation also, right? So we wrote this equation and we'll write the output equation. So what is the output equation? Y is equal to x1, right? So y is equal to, I'll put 1, 0, 0 here, and the state variables are x1, x2, and x3. Okay. So this is about the first state representation of your phase variables. Okay. So let us look at the case 2. Okay. So this is the easiest one, finding the phase variables for forcing function, which may not have derivatives of forcing function. Now, let us look at the next case. So it's very easy now. You just write the matrix and that's all. You will get the free marks. The next one, case number 2. What is it? State space representation of nth order system in which the forcing function involves its derivatives. Right? So your equation would be y to the power of n plus a1 into y to the power of n minus 1 plus a2 into y to the power of n minus 2 plus a n minus 1 divided to the power of 1 here plus a n into y. But the property means there is no differentiation. This is equal to b naught into sorry, b naught into e to the power of n plus b1 into e to the power of n minus 1 plus b2 into e to the power of n minus 2 plus b n minus 1 into u to the power of 1 here plus bn into u, right? So what is the transfer function for this? It would be T of S is equal to Y of S by U of S, which is equal to I have B naught into S to the power of n plus B1 into S to the power of n minus 1 plus B2 into S to the power of n minus 2 plus till this point B to the power of n minus 1 into S plus Bn. So just derivative forcing functions by S to the power of n plus a1 into S to the power of n minus 1 plus a2 into S to the power of n minus 2 plus a n minus 1 into S plus an. Okay. So in this case, how do you assume the state variables? So this is somewhat not typical, but it's a more systematic way of finding the state variable. So in this case, we use the first state variable x1 would be, so I'm writing here, x1 is assumed as the output minus, we have additional term called beta naught into u. We assume your first state variable. So you must remember these values. There is no other way. So, and second variable is x1 minus beta 1 into u. x3 is equal to x2 minus beta 2 into u. So that's how you can take x n minus 1 is equal to x n minus 2. Since it is x3 and x2, it will be xn minus 1. It would be xn minus 2 minus, this would be beta 2 now, beta n minus 2 into u. So what would be the last term? xn, the last state variable would be xn minus 1 minus beta n minus 1 into u. Okay. So I'll write it here. You must remember this notation. There is no other go here. You must remember all this. Now, what is output? Output equation. Your output equation from this output equation. Earlier, it was first state variable is your output. So, from similarly here also the output equation would be y is equal to x1 plus beta naught into u. This is your output equation. Now, what are the state equations? So, how do you get the state equation? We must take the first order differentiation for the state variables for all these variables. So, let us take that one. Let us take the first derivative of the x dot 1 would be, so what would be the value x dot 1 is equal to, it would be x2 plus beta 1 into u, isn't it? What is x dot 1? So you'll get, take the differentiation of this one. Differentiation, first I got the output equation from this, and I'll get the x dot 1 from this equation. Take the x dot 1. So it would be x2 plus beta 1 into u. So similarly, I'll get x2 dot would be x3 plus beta 2 into u. So I'll write the last equation. X dot n minus 1 would be xn plus beta n minus 1 into u, right? This is yours. Now what's the last one? So last one is always from the term domain equation. X dot 1 is equal to minus an into x1 minus an minus 1 into x2 minus a1 into xn plus beta n into u, right? So this is my time domain equation, the last one. Okay. Now, what is beta? Beta naught, beta 1, beta 2, right? Where beta naught is equal to b and beta 1 is equal to b1 minus a1 into beta naught and beta 2 b b2 minus a2 into beta naught minus a1 beta 1. So you must remember these beta values. Beta 3 must be equal to this practice you will get b3 minus a3 into beta naught minus a2 into beta 1 minus a1 into beta 2. So similarly, I will get beta n is equal to bn minus an into beta naught minus an minus 1 into beta 1 and 3 dots minus a2 to beta n minus 2 minus a1 into beta n minus 1. Now if you put in matrix form, that is your state equation matrix form, that put in matrix form. You will get x dot 1, x dot 2, x dot 3 and 3 dots, x dot n minus 1, x dot n, which is equal to So again, I'll draw the bigger matrix, and here I should have x1, x2, x3, and again I'll put three dots here, xn minus 1, xn, plus our B matrix and U. Right. So it is x dot 1, again it is 0, 1, 0, 0. I'm putting three dots here, 0, 0, and you'll get G. And what is this value? It would be beta 1, right? So now we'll get x dot 1. So x dot 1 is equal to x2 plus beta 1 u, right? So let us look at that. So x dot 1 is equal to your x2 into beta 1. Did you get the equation? First equation, right? So similarly, right, for all other values. So it would be 0, 1, 0, 0, 0. You get beta 2 here. Similarly, 0, 0, 0, 1. You get beta 3 here. So three dots here, three dots here. And it would be 0, 0, 0, 0. The last 0 and 1. And here we'll get beta n minus 1. So obviously last one is beta n. I'm writing here directly. So it would be an minus an minus an minus 1 minus an minus 2 minus an minus 3 and so on. It would be minus a2 minus a, right? So this is how we can put a matrix form. Now what about output equation? And we know the output equation. Your y of t would be again 1, 0, 0, 0, all zeros here, and you multiplied with your state variables x1, x2, x3 here, xn minus 1, xn. So what is the additional term here? Here you will get plus beta naught into u, right? Now you got the D matrix here. So this is your D matrix, right? D into V of t, and this is your C into, so this is your D into, and this is your C into x of t. This is your y of t. And here we know that if this is x dot of t is equal to a into x of t plus b into u of t, right? So this is about the second case, which has derivative values. Okay. So I hope you understood till this point. So let us recall. If you have any questions, you can ask directly. Shall we look at one example of this? Yeah. Example, it is y double dot mm, I got some I'll take triple dot here. Yes, 7 into y double dot plus 5 into y dot plus 6y is equal to u double dot plus 3 into u dot plus 2 into u, right? So now look at this equation. You have derivatives of the forcing function. So if you have another form, that is it is in the integral form, that is 6y dt or something like that, you convert them into differential equation. Now what's the corresponding general equation for this time domain equation? So whatever you have in the equation, you convert into in this one. Now what is the corresponding right here? Morning general equation is y triple dot plus a1 into y double dot plus a2 into y dot plus a3 into y is equal to b3 into u triple dot plus sorry, b naught. B naught, b1 into u double dot. I'm just writing the general equation, remember. b2 into u dot plus b3 into u. Since I need all these values, a1, a2, a3 and b1, b2, then only I can write the state model. So that's why I'm writing like this. So now what are the values here? Your a1 is equal to 7 and a2 is equal to what is a2 value? 5 and a3 value is 6 here. Now what is b naught value? Here I don't have triple dot, so b naught is equal to 0 and b1 is equal to 1 here and b2 is equal to 3 and b3 is equal to 2, right? So once you get all these values, look at this. Yeah, I got a1, these values. It's very easy to write the equation. The first thing is we must find out the beta value. Since if you look at this equation, so what are the values? You have A values and beta values. I know the A values, so that is AN to A1. So how many state variables are required? It depends on the order of the equation. So we have three variables. So that's why you have A1, A2, A3. So what is this? Minus A3, minus A2, minus A1. Okay. So I'll write general equation. Later we'll find the corresponding values. So it would be, our equation would be x dot 1, x2 dot 2, x dot 3 would be, it must be equal to, look at this, first one is 0, 1, 0, right? So I'll write here 0, 1, 0, 0, 0, 1. Minus an means minus 6, minus 5, minus 7 multiplied by your state variables x1, x2, x3 plus your beta values. Now what are the beta values here? It starts from beta 1. So it would be beta 1, beta 2, beta 3, right? So it is beta 1. We need to find out these beta values. Beta 3 plus into u, right? Now what are the beta values and the output equation? Recall that output equation, the first equation, C beta naught is equal to B. So the y is equal to x1 plus beta naught into u, and your beta naught, beta 1, beta 2, beta 3 values are these. So you substitute these values, you will get the answer. So try to do it here. So what is beta naught here? Beta naught is equal to B naught, right? Sorry, yeah, here I didn't wrote here. Beta naught is equal to B naught. So beta naught is 0 and beta 1 is equal to B1 minus A1 into beta naught. So beta naught already 0. So you have beta 1 is equal to B1 only. So what is B1 value in this equation? B1 value is 1 here. So I can write beta 1 is equal to 1 here, and beta 2 is equal to B2 minus beta naught 1 value 0, and is beta 1 is equal to 1. So beta 2, I need beta 2 value as 3, sorry, beta B2 is equal to 3, B1 is equal to 1. Is equal to 3 minus A1 into beta 1. Beta 1 is 1 here. So what is A1 value? A1 value is 7, right? So 3 minus 7. So it would be minus 4. So what about beta 3 value? So beta 3 value is B3, beta 1, this value is 0. So minus A2, B1, A1, B2. So B3 value is 2. B3 value is 2 here. 2 minus A3 beta naught is A2, A1. I need A2, A1. So what is A2, A1? A2 is 5, A1 is 7. A2 is 5. A1 is 7. So what is beta 1 value? It is 1 here. Beta 2 value is minus 4 here. So it would be 2 minus 5 plus, sorry, 2 minus 5 plus 28. So it would be 25. So what are the values? I have got 1 minus 4 and 25. We substitute these values in the matrix. Okay. So there you will get the state model. Okay. Now what is the output? Output is nothing but you have this beta naught value. So here beta naught value is 0 and you will get 1 multiplied by x1 only. So this is about today's class. If you have any questions, you can ask.